You are welcome to my channel, Gifted E-Learning. And today we'll be talking about separation of variables, a very complex and difficult question in calculus. But welcome to my channel once again. If you are new, kindly subscribe, like, and share this video as I'll be dealing on separation of variables. Okay? Like the name implies, separation of variables. This implies that the equation or the question we are having at hand, it's a complex or multivariable having both x and y variables separately, and they are mixed together. Okay, sorry. But we are asked to separate the variable in a way that x will be on its own and y will be on its own. For example, now we are having x squared dy over dx equals to x into y minus 1 bracket close. Okay, we are going to solve this question in a way that x is going to meet with the x alone and y is going to meet with dy. Okay, y minus 1 meets with dy. Okay, looking at this equation, where do we start from? We are having s squared here, we are having s here. Looking at the common thing we have here, we can simply divide both sides by s squared to eliminate this s here and this s squared here. Okay, eliminating this s squared here will leave us with dy over dx only. Okay, so let's try by that. Divide both sides by s squared. Divide both sides by s squared here. Divide both sides by s squared here. Okay, this will simply cancel this, and divided s squared by this is going to cancel, and this is going to remain only x because it's squared. This is cancelling, that's one x going. Okay, we are having the remainder dy over dx equals to y minus 1 over x. Looking at this question now, we are still having s and y on the same plane platform. Okay, we are going to look for a way to eliminate this s here. Looking for a way to eliminate this s here, what can we do? We can easily multiply both sides by s. When s is here, that s that is here can easily cancel out this s underneath, leaving this place to be left with only y minus 1. That is y minus 1, y variable on its own. Okay, let's do that. Multiply both sides by x. Multiply both sides by x. Okay? After multiplying both sides by x, you can see that this can easily strike out this, leaving x dy over dx equals to y minus 1 alone. Okay, you are seeing that s is on its own now, y minus 1 is on its own, just remaining this dy that is here. What can we do by this time? We have to eliminate this dy here to leave this side of the equation with x variables. Divided by dy on both sides, divided by dy on both sides, this dy can easily cancel out this dy, okay, leaving us with x over ds equals to y minus 1 over dy. So this is what we mean by separation of variable. S variable on this side, y variable, anything containing y on its own. Okay, this can be written as dy by taking the inverse, dy over y minus 1 equals to dx over x. Okay, at this point we have to take the integration. You have to take the integral of both sides. Integrating both sides, this can also mean 1 over y minus 1 dy, because when 1 multiplies, still the same thing. This is also implying 1 minus, okay, 1 times dx. When 1 multiplies, still the same thing. So that's going to give us ln y minus 1 equals to ln x plus the ln of the constant of integration. Remember, when we are integrating, we always add the c. Okay? So, at this point, we have to take the like terms. This is containing ln, this is containing ln. This can be written as ln cx multiplication ln y minus 1 equals to ln cx. Ln can easily cancel ln to leave us with y minus 1 equals to cx. Okay? Therefore, we are having y equals to this minus 1 here crosses over to the other side. We are going to have cx plus 1. So that's our final answer for this very equation. The second question, we have dy over dx is equals to 2x plus 5 divided by 3y minus 5. Okay? This can be solved easily. Take note, when you have dy and a variable containing y on the same line, that you can easily cross multiply for dy to meet with the y variable and the x to meet with the x variable, you can simply solve this by cross multiplication. I repeat, when you have dy and y variable on opposite sides to each other, then the x and s variable in a way that you can easily multiply for the s to meet with s variable and dy to meet with y variable, you can simply solve that problem of separation of variable by cross multiplication. Okay, let's say cross multiplication. By cross multiplication, we have 3y minus 5 dy is now equal to 2x plus 5 ds. Okay? At this point, we can easily take the integral of both sides. Taking the integration of 3y is going to give us 3y raised to the power of 2 divided by 2. Integration of 5 with respect to y, we are doing it like this. Just add y, that's going to give you 5y, equals to the integration of 2x is going to give us 2x raised to the power of 2 divided by 2. Then integration of 5 with respect to s will give us 5x. Okay, now you can plus the constant of integration. Okay, this will be further written as 3y squared over 2 minus 5y. Then this cancels this, leaving us with s squared. That's equals to s raised to the power of 2 plus 5x plus your constant of integration. Simple. So that's the final answer to that equation. So thanks for watching. So once again, you can subscribe, like, and share.